Hello, protocols, packets, and programs. Let's begin a March Madness for InfoSec myths, misconceptions, and mistakes. What are the recommendations that cause more harm than good? What best practices are based on outdated threat models? What advice sounds good but wastes everyone's time? How many factors make a good MFA? How many NPM packages does it take to write Hello World? How many developers don't care about security? How many AppSec checklists don't care about developers? Which means this week we chat with Emily Fox about the simple mistakes and complex foundations of a vulnerability management program. In the news segment, Silver SAML, more on pickling, the new IoT security testing guide, more memory safety, a little bit of CSF 2.0, and more. Scan a QR code and stay tuned for Application Security Weekly.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly.
This is episode 275, recorded March 4th, 2024. I'm your host, Mike Shima, and I'm here with John Kinsella. Hello, John.
Mike, good to see you. Don't mind me as I sort of shake out one last yawn.
Shake it out, and I forgot all the rest of the lyrics, so Swifties help me out in the comments. We are all, speaking of Taylor Swift, we're always looking for great guests for all of our Security Weekly shows. Submit your suggestions at securityweekly.com/guests. Emily Fox is a DevOps enthusiast, security unicorn, and advocate for women in technology who promotes the cross-pollination of development and security practices. She has worked in security for over 13 years to drive a cultural change where security is unobstructive, natural, and accessible to everyone. Her technical interests include containerization, least privilege, automation, and promoting women in technology. She serves as chair of the CNCF Technical, I'm going to get technology, I've messed this up so many times, the CNCF Technical Oversight Committee, and was co-chair for many KubeCon and Cloud Native Con events. Despite those technical difficulties, hello, Emily. Thank you for joining us.
Hello, Mike. Hi, John. It's a pleasure to be here today, and apologies for the very tongue-tied biography.
No apologies necessary. That was on me. Speaking of tongue-tied, there are a lot of people have opinions on vulnerability management, and will get their tongues tied. I'm not sure that metaphor doesn't work too well, but shouting about we got to fix all the vulns, which I think none of us here believe. That's kind of one of those starting points for misconceptions or just what's kind of wrong with vulnerability management. So maybe, Emily, you could help us just start off with what's a little bit of wrong so we understand what could we do better with VM.
So a really good example that I like to talk about vulnerability management problems is kind of like raising a child. The rule set and the practices that you employ for a 2-year-old are not necessarily the ones that you're going to do for a 19-year-old. So over the course of that time, you've had so many years of progressive development, lots of changes, new intellectual interests, passions, arguments, fights. And this is kind of the story of vulnerability management. We've been applying the same practices for the past 19, 20 plus years, and we've not actually taken a step back and reevaluated whether or not the current vulnerability processes that focus around box ticking and fixing all the vulns are necessarily appropriate given how much innovation and change has occurred within the technical ecosystem. We have a lot more open source projects that have code that is publicly transparent and following Linus's law of with more eyes, all bugs are shallow. We're expecting to see more and more vulnerabilities being reported to NVD, for instance. And that's what's been happening. As more democratization of software engineering and applications and technologies occur, more individuals are paying attention to what's in their code and what those vulnerabilities are. That's great news. We're finding them and we're fixing them, which reduces the probability that they're going to be exploited. But in reality, only 4% of reported CVEs are fully exploitable in the wild or even have proof of concept exploits. So when you're talking about those numbers and you actually look at how many vulnerabilities are being reported every single month, it's like something more than 24,000. It's getting exponential. And you also have that in a dynamic fashion because those are just the ones from like this past month or the month before. You've got 20 years of vulnerabilities that just keep stacking up that we're expecting software engineers to be able to understand what they are, how they apply to their applications, how they're going to be able to fix them, and then hunt for a patch if one is available. And the reality of it is, we've been doing this process manually for so long, it's kind of ingrained and we need to change our practices. We've matured as an industry. We've gotten better with our security practices. The check boxes are no longer working. And there's something better out there.
So there's a lot there to you set us up on many good paths to go down, especially some astute listeners heard that probability, which we'll come to in a little bit. But one of the, perhaps there's also a comfort level, or I'm going to use even the word, a nice AppSec word, risk, about, well, what happens if I don't fix all of the vulns? Because on the one hand, we might think, well, security is just a matter of quality. I want to ship quality software. On the other hand, I might think, well, what if we get ransomware, or the sky is falling, or there's a 0 day or something, extravagant that I'm a bit making up and being facetious about. But as we expand on this conversation, how should we think about that comfort level of what happens if I don't fix all the vulns? Is that okay?
So let's break that down. So the answer is always going to be it depends. And the reason why is because your risk is not the same as my risk, is not the same as a government entity. It's not the same as a financial services organization. And it's definitely not the same as some 18-year-old app store developer that's working on their first app and hoping to make it big. Like, the risk profile is going to be very different. And that is fundamentally something that has always been broken in vulnerability management, except in the most highly mature organizations. And even then, they still struggle. We don't understand what the actual risk of a vulnerability is in the context of the environment where it can be presented. On top of that, we don't actually really know what the probability of that exploitation is in our environment because we are not appropriately measuring the layers of security that we've instituted to prevent the likelihood of an exploit being successful and reducing the radius at which that exploitation is impacting an entire infrastructure or architecture. Like, when we're talking about stuff like that, imagine movie quality, highly secure organization with a map of this application sitting here, and my production level environment has this vulnerability. If it is exploited because there is a proof of concept out there, not even one in the wild being actively exploited by attackers or adversaries, but proof of concept, if that application is exploited, what is the impact within my environment? Which systems and services are going to be impacted? Do I have customers that are going to feel that impact? Do I have business data that's critical that's going to be exfiltrated as a result of that? Most organizations don't have that level of visibility, that really cool map that says, here, if it's exploited, this is the blast radius of it. And when we're talking about it in the context of a business or an organization, what is the cost of that exploit success? How much is that going to cost me in brand damaging? A lot of organizations cannot answer that. So they default to box checking because it's the easiest thing that they can do. It's a simple checklist. It says, fix all of the vulnerabilities. And if I do that, I'm told I should be okay, that I'm not going to be attacked. But the reality is there are so many more misconfigurations and exploits, like you talked about ransomware and malware, that are just the result of human error. And that's a lot of the other side of this vulnerability management problem.
Yeah, I love that you're bringing in, we're not losing sight of what we're fixing or how organizations are attacked, but to keep our focus on the vulnerability management side of things. Let's start to talk about some of those. Let's throw in some acronyms now. You were talking about risk, and I'll introduce CVSS to the conversation here, which I have to say up front, and in the spirit of myths and misconceptions, CVSS even says we're about severity. And you can throw in temporal scores, environmental scores, and that ostensibly becomes risk. But I think lots of people just don't approach it that way, or they just say, it's risk. The other part of that, though, that I want to ask you is, on the one hand, maybe we don't need to fix every single vuln. And I know you weren't saying we need to triage every single vuln and do a threat, a one-page threat model about everyone to figure out should we fix it or not. CVSS maybe gets us there, but how do we also just understand with 10,000 vulns a month or just some large number? That's where I'm pulling from. How do we figure out, which are the ones that we do need to fix or should fix or that are meaningful for our environment to fix?
Right. So you kind of nailed it. CVSS talks about severity, and that's really great because it gives us a starting point. In a generic environment with known levels of access, if this vulnerability were to be presented, how bad is it going to be? It doesn't take into account an individual organization's existing security controls or defense in depth measures. It is purely as it exists, observing the vulnerability in a vacuum, what the severity of that is going to be for the vast majority of industry. And that's great from a starting point, but we need to get to a point where we're talking about the probability of an exploitation of that vulnerability occurring within the context of a given environment. So EPSS, or the Exploit Predictability Scoring System, is a good mechanism down that path. It starts with severity and then couples in with the probability of exploit to allow you to have a more informed decision of, I have two vulnerabilities that are both critical. Which one should I spend my limited engineering resources on fixing? Is it the one that doesn't have an exploit, or is it the one that has a higher probability of exploitation within the next 30 days? And that's really what it is that we're looking for as an industry to start shifting to. Once you have that, it gets a little bit easier to take into account things that were part of your policy decision for your admission control, whether or not that application should be going in because you put all of the unit testing and regression testing in place, you did your source code analysis, you understand what is in that software, you have an SBOM you can cross-reference vulnerability information against, and you have a fully automated pipeline that says your developers are constantly cutting new releases of applications and containers and images that incorporates the latest and greatest updates that are found on the internet. So you're constantly working at the edge of where software is heading. And that, coupled when you have an EPSS kind of capability integrated into your vulnerability management program, that means that you're cutting out the vulnerability spam that happens. This is the low-hanging fruit that has been in NVD for years, and you should have just been doing it because it's a healthy thing to manage and buy down that additional risk that you're incurring, and doing it early enough in the process where it costs you significantly less than trying to fix something out in prod.
EPSS, I like the idea of being able to have an additional filter to help us figure out that we don't need to fit, what are the meaningful ones. We can also fall into traps, though, of I've seen a tool output an EPSS probability that was, I think, in 5 or 6 decimal points of precision, which sounds a bit skeptical. So, what's a healthy way just to take in something like predictability, probability that this will be exploited, and apply it to a program without worrying about a sky is falling or every 30 days suddenly reorienting all the priorities for our vulnerabilities, a big ebb and flow where developers don't have good predictability themselves.
Well, so part of that is getting standard practice with your development and engineering teams to be looking for and incorporating those updates as part of their regular sprint. Like, this is part of technical health and buying down technical debt, is that you're dedicating a portion of your time to ensure that you're pulling in the correct updates whenever you're working on a new software release. But the other side of that is to ensure that when you receive that information, you understand that vulnerabilities are dynamic. They are not static. An SBOM will tell you what is in a given piece of software artifact for the time at which it was packaged and made available as an artifact. It doesn't change with the next update. You have to cut a new SBOM. Vulnerabilities are slightly different, and that because it's cumulative vulnerabilities that existed in the previous version and have not been fixed in the next version, you now have to account for all of those. And attackers are constantly doing stuff. They don't take vacations the way that we do. And a lot of times their exploits are pretty annoying. They happen around days when we want to be on vacation or around the holidays, like we saw with Log4Shell. But the reality is, exploits will happen. They're continuous. They happen over time. So vulnerabilities need to be treated dynamically. You have to account for the fact that something that may not be a problem today, you just need to do a quick update, might become a major problem tomorrow or in the next month. And you need to be able to have the flexibility in your resource allocation and in your risk posture to make those changes. We don't like fighting fires, but the reality is, as long as there is software, there will be vulnerabilities, and the likelihood of that exploitation will shift over time.
So I want to go back and compare that with a really amazing analogy you made at the top about parenting and the 2-year versus 19-year-old. So everything you're describing, Em, sounds amazing, really great. I think some of us are lucky enough to be able to practice it. But what about the parent who maybe they were an alcoholic and the first 15 years of a kid's life were fairly miserable, and he was like, in someone else's home and all those horrible things. And before the 21st birthday, parent decides, oh my God, I've screwed up. I'm going to make everything right. I'm going to make sure my child has the best life ever. I think in the AppSec world, we've got quite a lot of that. So I'm curious from your experience, how does that, how do you show the love to that poor 20-year-old who's about to turn 21 and is like got all this baggage and all these years of insanity going on?
So a lot of times individuals, when we're talking about vulnerability management programs, or just generally, like the example that you provided, we show up and we overwhelm with information, and we overwhelm with, we're going to do these things. It's going to be a huge change. We're going to go down the right path. These are the new vulnerability management programs and practices that we're going to be instituting. But the reality is that we're still dealing with people. Security is always going to be a people problem, which means we have to take the time to upskill engineers to provide those education opportunities to migrate and transform a vulnerability management program. Today, most software engineers are probably being hammered with a queue of over 250 vulnerabilities that they are supposedly required to update to. But let's say, depending on the kind of program that they currently have in place, it's only just throwing every vulnerability in the world at them. It's not considering whether or not they even have the software in the first place to make it vulnerable. If it's a Windows vulnerability and you're running a Linux system, probably doesn't apply. So let's try to get rid of those. But you can't just make that giant shift in a vulnerability program, just like you can't show up and make all of these promises. You have to show incremental change. And there's a lot of different ways that organizations can start doing that incremental change with their software engineers. First is building trust. You need to understand what the problem is that developers are currently having with your vulnerability management program. What are the pain points? How are you communicating with them? A lot of times, and we saw this immensely across the industry with Log4Shell, is that every organization dropped everything they were doing and they threw engineers at the problem, which resulted in a few things. A lot of wasted effort by companies and by engineers in trying to understand who did what, is this updated, where does it exist in our environment, because somebody else was already doing that. And on top of that, they just spent additional time trying to communicate effectively when we were receiving differing information upstream around what the true vulnerability is. There were 2, 3 different vulnerabilities that came out at the same time, and one of them was correct and one of them wasn't. And then there was rumors about 1.0 is better than 2.0. Don't do the upgrade, go back to 1. And then there was some community upstream discussions around all of this. It's a lot of confusion. Organizations need to provide clear and explicit guidance for developers to start migrating to a new vulnerability management model and identify opportunities where they can pivot to make sure it makes sense for them and their business. And John, I see you've got an interesting face on. What are you thinking?
I think I believe what you're saying, but I think that still sort of is missing the recently sober parent of do they know that they have to provide their kids to use EPSS, not CVSS, or do they know that they have to go through this process? It feels like we've got a range of everything in the software world and in the enterprise world, but that I guess what I'm looking for is, where's the starting point for someone who decides it's time to start going to church, or pick your analogy. Is it, do they go to a specific vendor? Do they go to an open source program? Do they go start becoming a part of a community? How do they realize these things? But I mean, besides listening to us, like they obviously should be doing, Does that make sense?
How do you get started?
Yeah.
Yeah. So there's a lot of different ways to do it. And it just depends. You can start with an open source upstream community and start getting interested in their security vulnerability management triage. Most software projects have some form of security triaging team that you have to build trust within the community first. So that's a long path to get started. And even still, it doesn't make you more aware of CVSS scoring and how that's calculated. And it doesn't make you more aware about EPSS because as an open source project, you're probably not going to have the cycles to be able to leverage all of that information. And really, you're a software producer, so it's not quite going to be the same. And you're going to have individuals with expectations of you that you have to patch everything because your code is visible and they can see the problems and therefore they can write a proof of concept exploit. So please fix this now. So that happens. So that's one path. Another path is going to conferences. There are some security conferences out there. There was actually one that was just announced by First, specifically focused around vulnerabilities, which is actually very exciting to hear because previous attempts at doing a vulnerability specific conference didn't really get anywhere. We all showed up. We noticed that there was a problem and we came up with ideas to fix it, but nobody was actually capable or had the resources to start fixing them because we have to bring everybody in industry together. So conferences are a good way to start, but it's not going to be the end all. The next step is spending time and doing independent research yourself. If you're that parent that just showed up in your child's life and you're trying to make all of these changes, you need to do the due diligence and understand what the state of industry actually is first before you start rolling out those recommendations that you had in your brain. It's the same thing with a good manager. If you're a new manager to a team, the first thing you're going to do is understand what the current landscape is, understand what your team is working on, and then start developing next steps and strategies for improvement. So it really depends on the kind of person that you are, also what industry you're in, and whether or not you have the time and the energy to dedicate to being open and transparent and providing that technical leadership within a security ecosystem.
Along that vein, we've been talking quite a bit. And I led this here with my first questions about CVSS and EPSS. And, we have, the premise that we have a lot of vulns. We're just figuring out which of these vulns are more equal than others. So our animal farm of vulns, which ones we focus on. But Emily, you mentioned SBOM. You mentioned in the Log4Shell example, attackers out there, they're scanning and finding the instances, whether or not you have them as well. So I don't want to skip over the idea that there's also the simple to say, have an asset inventory. This is something that, what are perhaps some of the things that this, where we've gone with our very dark metaphor, this poor parent trying to get back to basics before they're even talking about vulnerabilities. What are some basic skills that they should be considering, or an organization that can help them just have a better experience when they get around to whatever maturity of vulnerability management?
So first and foremost, you have to know what it is that you have in order to be able to fix it. If you don't know what your assets are, what your containers are, if you don't know what's in them, you don't have the ability to effectively manage risk within your organization or apply vulnerability remediation practices. A lot of organizations still struggle in this. They're thinking about asset management from an IP perspective, like what's my IP address of my host? What are my machines that I have currently running in AWS? But the reality of it is that we should also be thinking about it in the teams that are producing that software. If you have a team that is working on a specific microservice with a series of artifacts, you need to be able to have both the asset inventory of what those artifacts are, but the team that's responsible for producing them. That way, when an artifact does show up in production and is vulnerable with a probability for exploit, you know who to go back to and ask, hey, can you pull in the next update so that this vulnerability can be remediated in production? We can cut the release. It'll go through our CI/CD system. It'll go to admission control and it should pass. And then it'll be redeployed and we're eliminating the vulnerability that way.
Just finding out who owns an asset, an artifact, that is such a hurdle that honestly feels even more difficult in large organizations in reality than like, oh, this is a CVSS 8.9 versus an 8.8. Do we really want to fix it today or can we wait till Tuesday?
Right. And a lot of the artifacts are being stored in a central location. So organizations have the data. It exists. They just need to be able to access it and use it effectively. And we see this a lot with software supply chain security practices as well that are now being applied. More and more organizations are producing metadata that's actionable and can assist in policy decision making. The challenge is that the data is being produced, but nobody's actually collecting it together to tell a story around what that artifact is. What is the risk associated with it? And is the risk that it presents tolerable for an organization to put it into production, to allow it to be visible and accessible to their users?
I wish this was true. And I think, again, it comes down to, let's be honest, I think you're lucky enough that you're working with some of the cutting edge companies and some of the companies you've worked at.
Yes.
There's a lot of places out there where I've seen the last few years where, they decide that they need to go through a FedRAMP, and maybe they had FedRAMP or pick your other certification, and they go for renewal, and they realize that they haven't been scanning things, or they find a system and they literally don't know where that system is in the building, or who owns it, or what's it running, or can we reboot it? Because that development team is gone. And
knowledge loss.
Yeah, this is part of where I'm, again, back to story that I wish I'll have to think of a different analogy than that drunken parent, but the parent that went windsurfing and they love it. They haven't come back from Hawaii. That's the part that, we joke in the industry that, we've been here 20, 30, however many years, and it's still, we can't get the inventory part right.
Yeah, 20, 30 years of technical debt. I was just talking about this with somebody recently. Newer organizations have it a lot easier. If you're a startup, as a business, it is so much easier than an organization that has been around for a long period of time. You've had to develop a lot of in-house applications just so that you can either consume software or develop software. And those organizations that have been around for a long time have this huge shadow behind them, or a ball that they're dragging and trying to push uphill, almost like Sisyphus, that it's just kind of constantly keep coming back to them until they draw that line in the sand and say, okay, we're going to start making the changes. Okay, we're going to start transitioning to something that's more meaningful for us. But they have to get out of this funk of it's a sunk cost. We've been doing it this way for so long, and not reevaluating whether or not the way that they're doing it is actually effective for their business or actually costing them more money. If you have a bunch of sit down and go through the process of, you've got a vulnerability that's been reported to you as a software engineer. You have to understand whether or not first it even applies to the software that you're responsible for. Then once you have that, you need to understand whether or not it's actually exploitable within the application as you've used that dependency, for instance. That takes a lot of time to do. Now, you've done that for one team. Now you have to replicate that for all of your teams within your organization where that particular dependency shows up. We're talking about a lot of human hours and mental effort sitting down and thinking about these things. And given that there's over 163,000 vulnerabilities that are reported over the course of, the past couple of years, and it's only getting exponentially larger, you're throwing 200 vulnerabilities at software engineers to sit down and do this. There's got to be a smarter way. We should be making sure that they only see the vulnerabilities that are actually exploitable, the ones that make the most impact to an organization and can cause the most risk. But we need to do it in a way that we're not spending everybody's time, because ultimately they're a software engineer, they're a developer. They want to develop applications and they want to see them show up in production. And they don't want to be reminded about the spaghetti code that they wrote 2 years ago that now has a vulnerability, because they're going to look at it and be like, wow, what did I do? I need to refactor this and fix this vulnerability. Well, refactoring is going to be a lot more fun because I can make it really cool and I can use the latest and greatest technology.
Don't say refactoring to Mike.
And on top of that, the White House wants me to start using memory safe languages. So that thing I wrote in C all that time ago, I should just write it in Rust now. All of these things go through a software engineer's head when we're talking about vulnerability management. And as an organization, you need to be thinking about this. You need to be doing it for them so that they can focus on the thing that they want to do, which is writing great code, delivering great products to your customers.
Absolutely. It's called DevOps. It's not called bug ops, as in fix this bug, fix this other bug, fix this other bug. That's a burnout. And I wanted Emily to pull us out of a little bit about vulnerability management in the sense of how do we avoid, how do we avoid the vulns in the first place, or how do we do something where we can not worry about a class of vulns? And here I'm trying to be optimistic. So let me figure out help me think if I'm being over optimistic or it's going to take another 20 years. And I talk about cloud or containers, just in the sense of asset inventory or immutability. Does that start to help, new organizations, new startups that are starting from scratch have lead into a better vulnerability management program? Or is this just different development environment from 20 years ago and we've got all the same problems?
It's a different development environment. We have all the same problems, and we have a lot more new ones.
Even better. So I've made it worse. Okay, help me be optimistic. Is there any silver lining here?
So we talk about eliminating whole classes of vulnerabilities, and to some degree, that is possible. Switching to memory-safe languages can assist in that, but it's not the end-all, be-all solution. If everybody in the world were to switch from writing in C and Fortran, COBOL, any of the legacy or heritage software languages that have been around for a long time, like the Linux kernel is mostly written in C. Do you know how much time and energy it would be to rewrite that whole thing in Rust? Whew. It's not something I want to do, and I don't know anybody else that wants to do it. So we have to live with the fact that there is some software out there that we're not going to be able to do this with. We're not going to be able to make the shift. We need to start relying on, like I say, defense in depth to reduce the likelihood of exposure to those things and understanding what those layers of security actually mean in the context of vulnerabilities that are occurring today. But beyond that, the next step is, how do you start automating those processes for your organization so they are no longer manual? We have the capabilities to do it. We've started with continuous integration systems to assist with building. You don't have software engineers rolling around on chairs in the hallway fighting with swords anymore because they're compiling their code. I mean, maybe that's still the case
Good
somewhere.
XCCD reference.
Yes. So there's a lot of potential opportunities that we have in light of a lot of the technical changes that have been occurring. If you can start creating software that doesn't have write up or write down, fully immutable, it's deployed, it does what it needs to do, and then it gets destroyed at the end. This idea of ephemerality and distribution with immutability is really where I can see industry heading within the next couple of years. Not just about eliminating whole classes of vulnerabilities, but preventing the existing vulnerabilities in the classes that exist from ever being exploitable within an application or within a workload that's deployed.
Now this is where we start to get constrained with time, and I want to jump around a couple topics because one of the things you did mention before is vulnerability spam, and this is a great. That's a trigger for me about just why did we even get this vulnerability report in the first place? Like who even cares? And one of the sources of this can be a bug bounty program. Now, that's not to dismiss them, but you do need quality control. And in the sense of bringing bug bounty programs into this, when should an organization do this? At what point should they start to consider, we need more vulns and we need to find out more and be told more problems with our software?
I would say that if an organization is interested in adopting a bug bounty program, they need to make sure their security practices are up to snuff and they have a red team that is capable of going through and penetration testing every single customer-facing element that could become exposed to a bug bounty program. Like, you need to make sure that you've got your stuff in order, your house in order, before you open the doors and start inviting guests in to wreak havoc. That's just the reality of it. And then once you have that in place, you need to ensure that you have dedicated resources for responding to those bug bounties, quality ones that actually understand your software soup to nuts, to make sure that you can get the most quality bug bounty reports. Now, remember, security researchers are out there. They're actively looking for vulnerabilities, and there are different kind of categories of quality security research. There's the ones that actually spend time with your products and actually look for exploitable paths, such as exposed endpoints, for instance, or let's say you accidentally exposed a secret in an application. They're going to be actively looking for those. But then you've got security researchers that are just going to run a scanner against your open source software code base, searching for keywords like denial of service. And and they're going to file a report on that because they got a hit on it. This happens a lot. And there are more and more of them, and software engineers and security researchers, even junior security researchers, are starting to leverage AI to look for vulnerabilities in software. And now you've got hallucinations of CVEs. So these are all it's vulnerability spam when somebody is not putting in the due diligence to actually discover whether or not the vulnerability is present or whether or not it actually applies. So the reality of vulnerability management in the next couple of years is going to be very interesting as more individuals get exposed to AI. We're trying to understand what hallucinations mean about this. Scanners are more accessible to anybody on the internet to hit open source software code repositories and say, I found a CVE, I'm going to be famous, and get it reported that way, because there isn't that quality control mechanism in place. It's inconsistent organization to organization, and it's even more inconsistent in open source, where we have a lack of security engineering expertise to be able to contribute to those projects.
And I think that, go ahead.
What do we call false negatives hallucinations?
I don't know that I've heard it applied that way.
Just
much better branding.
Keep going.
Yeah.
It is much better branding.
Speaking of, I don't know how I'm trying to segue off much better branding, but perhaps Emily, you've been working with vulnerability programs, tools. Do you have a favorite vulnerability that you'll actually be sad about when it actually is eradicated somehow because we've adopted memory safety or some framework or we fixed it as a class of vulns?
I don't think so, but I will say, over the years that I have been involved in vulnerability management and remediation programs, the Heartbleed, Shell Shock, those one had a huge impact on the future of what vulnerability management looks like. They're still out there. There's still software that's vulnerable. And then I would follow that up and say Log4Shell is another one, because that was the apex of where we started to find problems within industry. It really exposed a lot of issues, not only within organizations trying to remediate it, but within NVD and CVSS itself, and who owns the CVE, who owns the information that goes into that content that impacts millions of organizations worldwide in providing that level of remediation. So not necessarily happy that these will ever go away, but looking forward to what is the next vulnerability that will change the industry and how we operate and how we start asking these questions, because we've been hit time and time and time again, and we have yet to make a change. We talk about it, but we haven't done it yet.
No, we haven't. And I love those two examples, because real quick, Heartbleed did make everybody revisit OpenSSL and think, do we really need such a critical piece of software that supports 30 plus CPU architectures that are a bit obscure that nobody even runs anymore? And even Log4Shell was about, why did anybody even use this feature? Why was it even on by default? Nobody uses this. Why did we have this? So there's lots of good, secure by design, secure by default questions that can come into this.
Yep.
This also means there's so much more to talk about. Emily, we do have a couple links to the Red Hat blog. Are there anything else you'd like to highlight that people should be aware of about your work, about following vulnerability programs?
I will say that, one, start looking for those vulnerability conferences and those security conferences. See if there are discussions happening in the vulnerability management and remediation space. That is a good way to get started. The other thing that I will say is show up to those open source projects and communities. If you're a security professional, show up to CNCF's Tag Security, show up to OpenSSF, join any of their working groups. They're all working in the space, trying to reduce the amount of vulnerabilities that are present through best practices, through software engineering activities, through recommendations and scanners and tooling. But ultimately, we need more security professional contributions to open source projects. They don't just exist within foundations. They exist outside of them too. And they've been around for a long time, which means you're going to have to put in more effort to build trust within that community to drive that change. Because ultimately, if we don't get more of that expertise within open source projects, it's going to fall on the rest of the software engineering community and that burden, and it will be back in the same vicious cycle that we currently have today.
Ooh. Yeah, no more vicious cycles. And that leads me to one final question, Emily. We've been asking all of our guests this year we're putting together a bit of a yearbook of superlatives about AppSec. So help us complete this phrase. AppSec is most likely to
explode. We've got so much going on. I mean, how many people have had their entire work upended because of AI and generative AI? Pretty much everybody, right? When you start thinking about how that can be applied to software and the threats that come alongside that, like how do you know whether or not the code that was contributed to your project was actually from a person or was it AI generated? Like there's still discussions happening in industry of how do we detect that? We're built on this promise of trust within open source, but security is about trust but verify, and we're missing that but verify. So application security is going to explode over the next couple of years.
Well, I'm glad that you came on as a human amongst all the generative AIs out there. So this was very helpful. Thank you, Emily. And there's definitely a lot we can continue on. So we're going to have you back.
Okay. I would look forward to that so much. Thank you.
That's awesome. Thank you, Emily. Thank you, John. Thank you, all of our listeners. We're going to take a quick break now and return with news of the week.